Hello, good afternoon. My name is Jesus Mendoza. I am a student at Instituto Tecnológico de Pachuca. My research work is a study of wear due to reciprocating sliding in a titanium aluminum oxynitride coating deposit on H13 steel. Introductions. The TL-end coating continues to be the most accepted for applications in cutting tools due to its high hardness and resistance against wear and thermal oxidation. It is possible to improve the properties of TL-end by including oxygen by forming an oxynitride. The objective of this study is to evaluate the tribological performance of the TL own coating and apply it to cutting tools. Methodology. H13 steel specimens were made and the coating was applied in metaplast reactor. Titanium aluminum oxynitride was deposited. The crystal structure was studied with an XRD analysis. The coating surface was characterized by SEM and profilometry. The adherence of the coating was determined with a scratch test in an atom pair equipment. The wear tests were carried out according to the ASTM G113 standard using a tribometer showed in Figure 3, performing tests at room temperature and 200 degrees Celsius. Figure 4 shows the thickness of the coating obtained at 6 micrometers. Microdroplets and pores can be observed on the surface of the coating. In the cross sections, cavities and microdroplets can be observed. This is typical of PVD coatings. The coating has a columnar structure and will have good mechanical and tribological properties. The hardness of this coating is 22 gigapascals. Figure 5 shows the X-ray diffraction study. It was found that the coating has a high resistance to temperatures above 900 degrees Celsius. It has a face-centered cubic crystal structure with a lattice parameter of 4.16 angstroms. Figure 6 shows the dynamic scratch study of the coating. Acceptable adhesion was found with critical loads due to adhesive failure greater than 17 newtons. Figure 7 shows the scanning electron microscopy of the wear tests carried out by reciprocating movement in the steels. The formation of wear mechanics such as plastic deformation, adhesion, and debris is found. In the coating, areas with scratches, blowing, and spalations were found. Figure 8 shows the depths of wear. H13 steel presents greater depths of wear. The aluminum titanium oxynitride coating film presents the lowest depth of wear. This is due to its good mechanical and tribological properties, mainly due to its high hardness. Figure 9 shows the wear coefficients. The aluminum titanium oxynitride coating presents a high resistance to wear, which is why it has the lowest wear coefficient. This is attributed to the high adherence of the coating with age-certain steel. Figure 10 shows the coefficients of friction from the reciprocating sliding test. In tests at room temperature, the coefficients range from 0.6 to 0.7. However, in tests at a temperature of 200 degrees Celsius, the coefficients of friction decrease to values of approximately 0.2. This is due to the thermal softening of the materials. Conclusions: T-alone coating particles caused an increase in abrasion. It can be applied on cutting tools to increase their cutting efficiency and service life. The T-alone OXYNITRIDE coating presents good adherence. The adhesion failure occurs at 17 newtons. Thank you very much for your attention.